Hi, everyone. My name is Macarena Quiroga, and I'm a part of the Psych EarthStats Club. Today, I'm going to show you how to perform an ANOVA analysis using R. ANOVA, which stands for Analysis of Variance, is an extension of the independent two-sample t-test. We use ANOVA when we want to determine if the means of more than two groups are significantly different. In this case, we have several groups defined by a single grouping variable, which is sometimes referred to as a de facto variable. For this demonstration, we will be using the iRace dataset. As always, a good first step is to inspect the data. We will be using the view function. Remember, we can run a line of code by clicking the Run button when you are in that line, or you can press the keyboard shortcut Control Enter or Command Enter when you're in Mac. So in this dataset, we have the length and the width of the sepals and the petals of three species of flowers: Setosa, versicolor, and virginica. So we would like to know in this exercise if the width of these flowers sepals differ by the species they are. So before we dive into the code of the ANOVA, let's briefly discuss its assumptions. ANOVA assumes that the data is normally distributed, that the variances are equal but unknown between groups, and that the samples are independent. So to check the assumption of normality, we can use the Shapiro-Wilk test. We have to run the Shapiro test. Just to be clear, normality assumption. So we have to run the Shapiro test for the dependent variable, in our case, the sepal width, but for each one of the species. So we have to subset the dataset to run this test. So we have the function Shapiro test. We first retrieve the dependent variable that we want to use, the sepal width, and we subset those sepal width values for the species that we want to use. So first, we're going to calculate the Shapiro test for the species Setosa. And we can just copy this line of code to calculate it for the virginica and for the versicolor. So we can see based on the results of this test that none of them yielded statistically significant. So this means that our data is normally distributed. Then we can move on to assess the assumption of homogeneity of variances, or homoscedasticity, that it's also called. So we can use the Leven test from the CAR package. Homoscedasticity, it's a trick word, assumption. So we use, from the CAR package, we use the function Leven test. And the first argument is the formula. So we have sepal width, then we have the tilde, and we have the grouping variable or the factum variable, that is species. Then the second argument is the dataset. So the Levin test assesses whether the variance of the sepal width is equal across the different species groups. In this case, since the p-value is not statistically significant, we can conclude that the assumption of homogeneity of variances is met. So we can say that data is homoscedastic. Great. So now that we have checked the assumptions, we can proceed with the ANOVA analysis. However, it is important to note that if your data is not normally distributed, you may consider using non-parametric tests such as the Kruskal-Wallis or the Friedman test. Additionally, if the assumptions of homogeneity of variances is violated, a Welsh ANOVA can be used. So let's perform the ANOVA analysis using base R functions. We will use the function called AOV, analysis of variance, and the formula is the same that we used for the Levin test, so we can just copy and paste it. And we would like to store these results, in an object called iris ANOVA, because we are going to reuse it. We can use the function summary, the summary function, that it's a great function to see the results in a tidy way. And we can see that the summary of the ANOVA output shows that the ANOVA analysis is statistically significant. However, it doesn't provide information about which specific groups differ from each other, because remember, with the ANOVA, we have 3 groups. To determine the pairwise differences, we can use the Posthoc test, such as the Takis honestly significant difference test, also called the Takis correction. So, for the Takis correction, we use the function Taki HSG with the object we've just created. Please remember that R is case sensitive. So if you write this function in small caps, like Taki HSD with the same object, it will return an error. So please bear that in mind. So we run the Takis correction, and we can see that the 3 groups are different from each other. Alternatively, you can also use other post-hoc tests, such as the Bonferroni correction or the Holmes method, to adjust the values, the p-values, for multiple comparisons. So, for example, if you want to run a Bonferroni's correction, we can use a function that we can also use to calculate a t-test, and we specify that we want a Bonferroni correction. So we use the function pairwise t-test, and we use for the first argument the dependent variable, that is the sepal width. The second argument is the grouping factor, species, and then we specify which kind of adjust method we want. In this case, for example, we want Bonferroni. If we want to use the Holmes method, we only have to change that last argument. You can see that the p-values are slightly different between these corrections, but the overall conclusion remains the same. So I would like to show you a package called EarthStatics, which simplifies the ANOVA analysis. It has a lot of statistical functions and is also pipe friendly, which means that it's compatible with the tidyverse function. So if you use tidyverse in your daily work, maybe you would like to check out this package. So to use this package, you will need to install it first with the function install packages. Remember that you have to use the name of the package between quotes. Then you have to load the package with the function library. I already have it, so I didn't need to install it. And with this package, we can perform an ANOVA analysis. We need to use the function ANOVA test with the formula that you are all familiar with. That is first the dependent variable, then the grouping variable. And lastly, the data we have to use. The summary of the results provided by this function, the ANOVA test, include not only the p-value, but also the effect size that is here, the generalized effect size. By default, this test, the ANOVA test, calculates the ANOVA test function calculates a generalized eta squared, but you can also calculate a partial eta squared if needed. You just have to specify it in the function. You can copy the same function and specify that for the effect size, you will want the partial eta squared. So here you have. You can also run a Takis correction with AirStatics. The function is Taki HST, and you have the formula that you already know, sepal width, and the grouping variable species. And the data set here is specified as an X argument. And here you have. So overall, these are some approaches you can use to conduct an ANOVA analysis in R. I hope this explanation helps clarify the process for you. And if you have any questions or need further clarification, please let me know. Bye-bye.